Let's dive into geometric sequence. Let's see what it entails. We'll also try out some examples to help you best understand how to treat questions. In the previous video, we talked about sequences. We focused on arithmetic sequence. And if you want to learn more about that, you can actually check it out in the description below. Today we'll be talking about geometric sequence and what it means, and how exactly we can answer questions involving geometric sequence. Geometric sequence, or exponential patterns, whatever you want to call it, is a set of numbers in which has a common ratio. And what that literally means is that whenever you divide the second term by the first term, it should give you the same answer as when you divide your third term from the second term. Now, it doesn't have to be these two sets of values. It could be consecutive, any consecutive term or specific. It could be T100 divided by T99. You expect to get the exact same answer, right? For it to be a geometric pattern. To answer geometric sequence questions, you will either be told right off the bat that it is a geometric sequence, or you could find your value for R, like what we talked about a minute ago. The formula for a geometric pattern is Tn is equals to A times R to the power of n minus 1. And your A represents the first term, your R represents the common ratio, your n represents the number of terms, and finally your Tn represents the value of the particular term. We normally use this to answer any question that involves geometric sequence. Now let us try out some examples involving geometric sequence to help you best understand how to apply this section. The first question we have over here says we have 2 over 3, 4 over 9, 8 over 27. That is our pattern. So we were first of all asked to calculate the R. So obviously, like we said, the R is your common ratio. So all we just need to do is divide, as you can see there, the T2 by the T1, right? And that definitely is going to give you your R. For you to be 100% sure you're right, you can do it again, divide the T3 by the T2, and see if they actually do give you the answer. So let's try that out real quick. So as you can see, you get the same answer, right? You get 2 over 3, where R is equals to 2 over 3. Whenever they ask you to find your general term, meaning that you're going to substitute your A and your R into your geometric sequence formula, right? So I'm literally going to put A, which is 2 over 3, R, which is 2 over 3, into this particular formula, right? Okay, so let's try that out. So this is perfect like this. This is your final answer. But if you want to simplify a little bit better, you would need to use the laws of exponent. And this would be your final answer. Then finally, for this particular example, the next one they ask you to do is find the 10th term. To find the 10th term, all you just need to do is substitute your value for n as 10, right? So I have my formula from my previous question. So I will just replace that with 10. Either one of this is right. So the next set of questions we're going to go through is when you're given two terms and you're asked to determine like your A or your R. So like you see this particular question, you're told that you're given the 9th term, you're given the 6th term. The values for both of them were 80 and 10. But now they asked you to find A and R. We did something similar in the arithmetic sequence, which I also said in the description below. We can use the exact same method we used in that video in this one over here. We're still going to use simultaneous equation. Whenever you have a question, when you have two unknowns, is recommended, actually, is the only choice you have is for you to use simultaneous equation. Now, for you to use simultaneous equation, you first of all have to have two unknowns. Check. Secondly, those two unknowns can give you two equations. Double check. So for that reason, simultaneous equation can be used. Okay. So what do I mean by this? So this is what I'm going to do. I'm first of all going to put all this into the Tn formula. So this is the formula you're going to use. So I'm going to put this into the simultaneous equation. I'm going to use the elimination method to try to answer this question. And how I do that is by dividing equation 1 by equation 2. So now we have the R. To get the A, just like any simultaneous equation, you substitute into any of the two equations. And this exactly will be your answer. So we have our A and we have our R. On to the next one. Now this question says that find the N if your Tn is equal to 5120. Okay? So if we're going to try to do the same thing, we're going to use the same formula. The good thing is that we just calculated our A and R in the previous question. Simplifying is definitely going to give you this. Now, you are also going to use exponents to help you simplify this again, right? You will break this 8192 to its possible exponents, and that's exactly what we're trying to do here. That's all. I hope those examples helped. A couple of things you guys need to remember. Whenever you're working with geometric patterns, try as much as possible to stick to fractions. Do not use decimals. We'll be tackling arithmetic and geometric series next. Do check out our videos on sequence and series in the description below. Thank you.